Hey there, Calc 3 folks, back here with a demo lecture. I think this is the first one that I've done for you folks. I've done a couple over on my playlist for my Calc 2 students. I've put together some things to help them out with sequences and series on Mathematica and looking at the tests for convergence and the like. But I'm back here for you folks today to give you a quick little graphing demo. As you might take note, this idea of multiple integration occurs over regions, right? Regions that can exist in two-dimensional space and regions that can exist in three-dimensional space. And some of this analysis and some of our success in this analysis relies on us being able to understand these regions over which we're integrating. So what I wanted to do today was show you some ways to go about putting together some plots on Wolfram or in Mathematica to help you out with your study of multiple integration, right? To help you generate some of these graphs that you might be seeing, defining your spaces, your regions over which you're integrating, right? So if you haven't signed up yet for Wolfram Cloud, I strongly encourage you to, as a student, folks. I did go ahead and log into, I've got my web browser open here, and the website is lab.wolframcloud.com. You can see that up here at the top, right? You want to jump into that web address, right? And when you head to that web address, it will, if you've never been here before, drop you at this page where if you scroll down a little bit, you will see that you can sign up for a basic plan for free, folks, right? And you can see that I do currently have a basic plan once I log in, and you'll be able to notice that it has never cost me anything, right? And I've stayed with a basic plan, and I've been able to do quite a bit on Mathematica, both in my studies here, right, as well as just out in my free time. I've been able to do a lot on Mathematica, and I've never had to shell out a penny to use it. And it's been really helpful, folks, as I've been trying to get through the last couple of weeks and putting together some of these illustrations for you, and not that I'm presenting to you in these online lectures. So, and I've been working with Mathematica not very long. You know, I'm a newbie at this too. It's really been this since maybe the start of the semester where I've done a heavy study into how to use Mathematica, right, and the functionality of it, and its it's programming language, right? It is a bit of like a mathematical programming language that's based upon really the idea of sets, right? Set theory, in a sense. At least that's what I'm taking from it in my study, and that's kind of what we will see happen in as you continue to work with it here. Hopefully, you will gain some understanding of this programming language. And again, like I said, I found it extremely useful, and it's free, right? I've been using it all along here, and it's been free, and my skills have just strengthened and grown over the last couple of months. And even the last couple of weeks, as we've been tackling what is currently our task in front of us here, right? So when you go to this web address, it will drop you here at this page. You'll want to sign up for an account if you don't have one already, folks. And then once you do have an account, you can just sign in. You can see here I signed out. Just a moment to show you this. I'll go ahead and sign in with my account. And it will drop you on this initial page, folks. This is a couple of places over here on the left. You will notice all your files will be stored in Mathematica, and it saves everything here to the cloud, folks. So I just encourage you to, if you can, make sure that you're giving good titles to your documents, and you are naming your documents so that you can go back and find them later. And this is where we're going to actually see the Mathematica window open up here when I open up a new notebook in just a moment. But I also wanted to show you here that they do have some handy tutorials presented over here on the right to get you started if you're just needing a couple of hands-on intros to start learning the language. And then likewise, there's you can search any command on here, folks. They have a really extensive wiki of information here. Where you can get on and see how to use the commands, how to see all the options and the details for all the commands. All that can be found either by doing a little search up here, or going online and doing a search Mathematica with the command that you're looking at, and so forth. So, I just point these out to begin with. I'll go ahead and close this out for the moment. We'll just jump into a new notebook, and it comes back right away. Let's go ahead and get rid of that entirely for just a moment. Now, I may get in there every once in a while just to look up some of the commands that I'm going to share with you here today. As I noticed here, it is a basic plan, folks, that I am using. I've paid $0 for this plan, and that it's been extremely helpful at a cost of nothing. So I will say that that so far you may want to get in there and get signed up. With respect to giving your document a name, this is over here, right? If you actually click on that portion that says unnamed, it will give you the option to put in names. So maybe I'll just title this Calculus 3 Graphing Demo, right? I just want to give it a name so that I can find it later. If I don't give it a name, Mathematica is going to give it a very obscure name consisting of a bunch of digits and numbers, and you will never find your document again once you get a good collection of documents in here. And if you don't name any of them, things will get lost forever in the system. So make sure that you are naming your documents. That's I've spent a few moments at times looking for things I've forgotten to name, and it does take a while, folks. So I'll go ahead and name that, and you can see down there it does tell us that things have been named, right, for us. Across the top here we have some menu commands, just some menu options like files, how to manipulate the file, some format commands, right, with respect to cells in this program, and the cell styles and such, text formatting, cell formatting. There is an insert command. I've used the special characters. I haven't done too much hyperlinking, and with respect to images, it's drag and drop over into this system. In evaluation, I have done a little work over here in the evaluation window. Occasionally, I'll get a program that I've written that crashes on me. I've just manipulated the variables to an extent where it is all mixed up with its variable values. So I've had to come over here at times and either delete all my output, or what I often suggest is if a program is crashing or just not behaving as normal, I would delete all the output and then I would quit the kernel, right? Delete the output, quit the kernel, and what it does is basically quitting the kernel erases the Mathematica memory. It erases all of its understanding of all the variables that the program has established or that you have established through your programming. So it's kind of like not erasing your program, but erasing all the variables values within that program, and it starts you off fresh. So I often encourage you doing that if you are just not seeing performance like you should from a program, right? Maybe deleting an output and quitting the kernel. And at times, if things really do crash, you may consider restarting the session, right? Other things, view, have never been in view, and like I said, help, I often go up to the magnifying glass up here to help, right, to seek out some help, right? Now, underneath the menu bar here, where we put in our title and we saw those menu options, you will see what we maybe call the Mathematica Entry Bar. It's this horizontal line with the plus sign in a circle over here on the right, where if you put your cursor over that bar, you will get that that line segment, right? That horizontal cursor, where clicking now on that bar will put the cursor into that bar where you can start to insert some Mathematica commands. Now, I don't know if this will show up on the video. This often doesn't show up on the video, but you can change your first of all, when we put a command into Mathematica, let's go ahead and put a command in here. Maybe we put in the command 2 plus 3 times 8, right? That is an entry into Mathematica. It is sitting in, you may not be able to see this. Maybe I should, let me see here. Can I, Bring my window a little smaller so I can show you the side menu here. All right. What I want to show you is over here on the right, and that was off screen, is that this highlights then this command going into my Mathematica as a cell, right? And since I didn't change around any of the command options for the cell, any of the cell formatting here, it's going to take it as just a typical Mathematica input, right? And it's kind of highlighted that this is the cell that I'm going to input into Mathematica. Now with my cursor still within that cell, right? Either waiting for more entry into that cell or waiting for me to run the command of running that cell, what we can do to actually produce this calculation to make Mathematica go through the process of taking 3 times 8 and adding the 2, right? Because it's going to follow the typical order of operations we would expect here. The way that we enter that command into Mathematica is we don't hit enter. Enter just moves us to the next line in the cell, where I could come along and put in another command. Maybe I take 4 times the quantity 5 minus 1, right? Or sorry, 4 minus 1 here. So that would be 4 times 3 in value, right? All that did was put another, you'll see here, it extended my cell, right? It did extend my cell, right? Another line, but it didn't really run this code yet. And what I will now have happen, if I do go about running this code, I will actually get these 2 lines of output for my code. Mathematica will call this line 1 of input. Mathematica will call this line 2 of input. And what it will give me is output with respect to line 1 and 2. I believe it'll call it out 3 and 4. Let's double check that. Actually, I think it will call it output 1 and 2. But now, how do we make Mathematica commit this operation, right? To actually commit to running this these calculations, is you hold down the shift button on your calculator, or on your keyboard, sorry. Hold down the shift button on your keyboard, which your computer is really just a giant calculator anyway, folks, but hold it down on your shift board and hit the enter button, right? If you hold down shift and you hit the enter button on your keyboard, it will run those as outputs, right? That is one way to get Mathematica to run this command cell, right? This cell containing these, well, what we might call our code or our program here, right? Our calculations of interest. We went through the process of just holding down the shift button and hitting enter, right? And you'll notice each time that I do hold down that cell button and hit enter, and I'll actually zoom in so you can see this a little bit more clearly here, is it does tell us this is our input. Here I've actually ran the code twice now. First time it said this was input 1 and 2, and this was out 3 and 4, right? Now it says this is input 3 and 4, and this is going to be the output corresponding to the input of 3, and this is going to be the output corresponding to the input of 4. What you will notice is that Mathematica will only list the first input, and each one after that will just increase numerically, right? This would be considered output 4, well, input 4, which produced this result of 12 for its output. All right, you will see how it organizes the cells over here. This is the entire group of these inputs and outputs. Here is the input cell. Here are the 2 corresponding output cells. All right, if I want to delete a cell, I can just highlight it, hit the delete button. It will delete away those cells, right? And I could come back and re-input this again, right? Where you will see that Mathematica, and this is really what the kernel is somewhat keeping track of what were your inputs and your outputs and your variable assignments. If I wanted to start fresh and new, I could go back here, just simply delete all my output, quit my kernel, and you can see Mathematica kind of goes back to a nice fresh start where I can run this all again, starting with new outputs and new inputs and new output assignments, right? All new variable assignments, right? Now that is one way to have run code, is with the shift enter. The other way to actually get it to run your code is if you go over to your what do we call that? Your numeric keypad. So if your calculator again, if your computer has a numeric keypad off to the right hand side of the alphabetic keypad, you can hit the enter button on that keypad. If you number lock that keypad, that enter button alone, you don't need to shift enter, and it will actually run the input. If I do that here, I'm just going to go over to my keypad, hit the enter button, and I don't need to hold down the shift, and it will do these calculations for me, right? Shift, 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 and it goes through that and performs those calculations, right? Let me go ahead and delete out that. That is putting, right, information just into a cell, and you can saw there I put in some really basic calculations, but Mathematica does work, can work in a very complex nature also, right? For instance, right, instead of working with numerical values, I could define some functional values, right? I could consider taking function. Now, here, let's maybe build our understanding of functions this way. In Mathematica, the way that the programming language works is with what we call wrappers. That would be WRAPPER, right? It works with what we call a wrapper. What is a wrapper? It is essentially an operation in general, right? That Mathematica understands as a calculation, right? Followed by, well, I should say here, being applied to an argument, right? We're going to apply this to an argument. And the way that we apply this operation to an argument is we wrap it around that argument using some brackets, right? This might be considered our general understanding for how the programming language of Mathematica works here. We have maybe what we should say here to start off with is an argument where we take that argument and we wrap it in some operation. We perform an operator on that argument. All right? Now, one of the simplest functions that we can apply to an argument, well, let's be careful. Let's go back. What's the simplest argument we can have? Simplest argument you can have is just a variable or a number. We've looked at numbers already. Let's come back and look at just a variable, x, for instance. That is a very simple argument. We could argue x to be a lot of different values if we wanted in this case. And what we might consider coming back here and doing is one of the very simplest operations on Mathematica that is extremely convenient and useful to us. And that is going to be defining a function for some argument of x, right? In a sense, applying a functional understanding to the value of x. And the way that we do that in Mathematica is we wrap our variable, our argument of x, with those brackets, right? And we go out in front of those brackets and we apply what is considered a non-reserved variable description here, or a non-reserved functional name, we might say. There are a lot of commands that are reserved in Mathematica. If I, for instance, came and tried to use the word sum here, right? Mathematica is going to tell me I have a problem with summing. Or if we go up and we actually search under the window here for the word sum, right? We will notice that sum is a very specific command used in Mathematica, right? So I'm not going to want to declare a function as any particular mathematical operation that I'm familiar with. I'm going to want to keep it very generic in its name, or something that isn't reserved for a command or an operation in Mathematica. And what I might actually just call this, with a little bit more classical notation, just function f, right? Where, to begin with, this does look like function f, right? F of x here with this f bracket x. But this is how we go about calling up function f. If I actually want to start by declaring function f inside Mathematica. If I want to, in a sense, think about putting function f into Mathematica so that next time that I bring up function f in the program, Mathematica understands it, I do have to go into the brackets, and behind my argument of x, I want to indicate to Mathematica to reserve this x for a variable value. And the way we do that is we follow the variable in our functional argument here with an underscore. All right, that is just a shift minus sign will produce an underscore. And what I will then do is go to the outside of this argument to the right and actually now start to declare what is function f. And you can see when I put that equal sign there on the right, it's kind of changed up the notation here for f. It has gone about and said, yeah, here I'm ready for function f, this function f, where the independent variable is x. And you can see the blue coloring to f, right? That's a way of Mathematica starting to say, yeah, I'm going to think of this as really a variable value, right? Where this variable value is going to now take as input this value of x. This variable value is going to behave functionally, right? It's going to produce an output for a given input, right? Where Mathematica is expecting you to input now or have x be the variable value inside this equation. What's a variable of x or a function of x we might define? Maybe we define a quick polynomial, something like 1 plus x squared, right? That is a function of x. And if I hit enter, right, all Mathematica is going to do is spit that out as the output. All right. If I was to follow this up by maybe, let's go back into this command here, window, and not only put in f of x, but put in the statement f at then the value of 0, right? We all know what that should be if we plug 0 into our function there. Being a polynomial, it's just going to leave behind the constant. All this would just equal 1, right? And when I enter that in as a command, I get back both my function for f and I get the output of my function when I plug in the value of 0. All right. Now, Mathematica is very much a symbolic language. It applies these operators. It can apply them on numerical values, and it can apply these ideas, these concepts, these operations built into Mathematica on symbolic values. Right? It's a symbolic language in a sense. I could come along and think about finding f not just at a numeric value. I could compose into function f some other function. Maybe I want to plug into f let's go with the square root function. How do you put a square root into Mathematica? Well, you are going to take that argument of x and wrap it with the square root argument. Now, SQRT is a reserved term for operation for square root, and this is telling function f, right, to evaluate itself at the square root of this argument of x. All right, and if I enter that into Mathematica, it performs that calculation. Right, it goes through function f, and everywhere it sees an x, it plugs into the square root of x for those locations, and it does a little simplification along the way. Right, we can see this x turns into the square root of x. The square root of x squared then just becomes the value of x. Right? And I could even get more complex than that. I could go and decide this function for x that's being squared and maybe wrap that independent value of x with maybe the cosine of x, right? With the cosine argument. Now you'll notice here how the trig arguments have to go in, is they do have to be dropped in with the, a lot like the square root, being treated as a functional or this operator being applied to argument x. And if I now input that into my calculator, I get this result, right? Where not only is it plugged in the square root of x into all the arguments of f at x, it's all plugged in the square root of the cosine of x in those arguments, right? And I could build this up for any level of composition I would want within this function of x, right? Now, you can see here it's starting to get a little cluttered. one thing I like to do, and this doesn't always show up on, this is what I was talking about earlier, not always showing up inside of our cell, is I often like to highlight my program cells with a little code formatting. And you can format your cells to be different types of what we might call inputs, right? Or different types of what we just call, well, what line formatting or text formatting, I maybe should just say. I could, for instance, title the cell as more of a title, which now it's not going to, if I try to input that, it's not going to input anything, right? I can hit Shift Enter all day long, and it's not going to treat that as an input cell anymore. It's not until I hit, I believe it's Alt 9, that it will go back to an input cell. But if I hold down the Alt 8 button, and I don't know if this shows up in actually in my video here, but if I hold down Alt 8, I will get the cell to turn into a light gray in color, which helps me to identify that this entire cell is being treated as one input, or it's kind of thought of as a single program here, right? It helps me keep track of my Mathematica programs. Now, the other thing you'll start to notice that will kind of clutter up your picture a little bit here is if you start to take, for instance, more than one quantity, right, into Mathematica. Maybe we go with this being the 2 times the sine of x, right, minus the exponential function. Now that would be the e function, right, e to the x. Well, let's go e to the 2 times x, all right? And then we consider maybe coming down here and saying, well, let's take function f at x and add that to now what's going to be 4 times g of x, right? Or let's consider maybe what would be the value of f at 5 plus 9 minus g at 6, right? Or maybe we want to do a bit more complex calculation where we want to actually find the limit of function g at the value of x, where x is approaching infinity, right? And if I go along and input that program into Mathematica, you will see that it gets rather bulky in its outputs here. I had 5 lines of code, right? Starting at input 20, you had input 20, 21, 22, 23, 24, right? And down below, we see the outputs for output 20 up through output 24. And it does get a little bulky here. First of all, spitting out functions f and g, and then spitting out these compositions or these arguments based upon f and g, right? So there is a couple of ways to kind of reserve, right? Well, to tell Mathematica to not give you a particular output, right? In a running of a program. For example, here I can tell f here, Mathematica, not to, for instance, to tell me what function f and g is by simply following that with a semicolon. If I follow each of those lines of code with a semicolon, right, and I input that in, now it will not tell me the outputs for f and g in this output. It says your input starts at 25. This is input 25, 26, 27, 28, and 29. It just gives me the outputs for 27 through 28. Right? If I wanted to leave out the f plus g, I could follow that with a semicolon, or even this with a semicolon. And when I run that output now, it's just going to calculate the limit. All right? With respect to relationships between variable values, this defines f, right? When this argument is, or this line of code is encountered in the calculation, there is a way to make Mathematica reserve defining f and g until it's called upon later in the calculation by using what we call a set equal symbol, or a set equals, or a set delayed symbol in the defining of our functions here. So here I have set delayed defining function f, and I have set delayed defining function g. All right, that means Mathematica looks at these but doesn't define these. It goes, okay, I have these functions that are being set delayed back here. I will come back and worry about these values when I actually encounter them later on in my code. All right? It's what we call set delaying our functions. And sometimes you might want to set delay versus just set a function equal to a variable value. And sometimes you're going to want to not be set delaying values, right? Where you might have to rely on the semicolon to not show those values. Now you will see here, if I take away all the semicolons and I use the set delays on function f and g, again, f and g are now not reported, right? Mathematica basically treats them not as something you want an output for. It's not going to worry about those functions as outputs until they are called upon later in the calculation, right, or later in the program that you are running. All right. So here, folks, all I've done here with this first little bit is just start to show you how to work within this system for Mathematica. Now let me come down here and show you some things related to graphing. All right. Let's start another graphing window. All right. Excuse me. I'm going to open up here. I'm going to hit Alt-8. This is what I like to do, is I like to highlight my inputs as a bit of code in a sense. So I hit Alt-8, and this enters into what we call the code cell, right? Where this will help me identify that this is the code that I'm producing. What I might also do is go ahead and I'm going to delete all my outputs, and I'm going to quit my kernel, and I'm going to kind of start fresh down here, right? I'm going to want to define a new function for x. Maybe we define the function equal to x squared, and I am going to set delay that, you'll see here, folks. I really don't care about getting output f from Mathematica. What I'm going to be introduced in doing down below is running some operations on x. Now, with respect to making a table, you can certainly look at individual tabled values by just evaluating f at values. Like if I want to find the function f at the value of, let's go back to something that we'll actually see the algebra a little bit more distinctly. If I just want to find f at 2, right, I could find that point. Now, you will run into this when you erase all the cells and then delete the kernel in the middle of a program. I always suggest just hitting no, right? So if you hit yes on that previous command, what you will see happen is it runs all your code, and sometimes it'll produce duplicate code, right? So I usually just hit no on that. And what you see here is we do have basically our point, right? This is 2, 4, right? If we consider that a point. Or I could even come back and say if I wanted to have Mathematica tell me this as a bit of a coordinate, I could note that a coordinate is really basically just a set, right, represented by an array of 2 values here. This would be the coordinate 2, f at 2. And if I hit enter, Mathematica will tell me that coordinate, right? 2, 4 would be our coordinate there, right? I could even more so come along and even, if I wanted to be fancy, right, define this coordinate basically as a function of x, right, where this function in terms of x could come back and be ran, right, for any particular value, right? I could find it at g of 4. Now this should produce the coordinate 4, 16. Or I could come back and find maybe g at 9, right? That should produce 9, 81. All right. So you can see here I can not only define a function to be just a single value, I can define a function in Mathematica to actually be a set of values, right? To be a set of coordinates here. All right. Now, that's going a little over the top for just the moment. What I might want to consider, though, doing, instead of just looking at a few specific points on a graph, maybe I want to make a table of values. All right. To do tables in Mathematica, I might want to make a table of coordinates here. So I am going to take the table wrapper, right, the table operator, and I am going to want to wrap it around function f of x here. Well, I'm actually going to want to wrap it around the coordinate I can build with function f at x, the coordinate x comma f at x, right? We're inside this table, right? I am going to want to, right, build this table for this variable value of x, beginning maybe at the value of 0 and continuing up through the value of 10. Right? And this is the command I would put into Mathematica. And if I wanted just to double check that command, I could come over here to the list or to the search menu and notice that there are a couple of ways I can input the table command into Mathematica here. And what I've chosen to use is this one right here. This is going to generate a list of values of an expression, right? My expression being this generic form of the coordinates for this function, x comma f of x, starting, well, actually, I'm using this one, all right? For values in the table where x playing the role of the index I in this case, starting at this minimum value of 0 and continuing up through the maximum value I have here at 10. And if I input that in now, you will see it builds that table, right? That set of coordinates 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, and so forth, all the way up to 10, where we have 10 comma 100. Right? Now, one thing you might want to do is plot these points. So one way we could come along and plot this is we could say, let's take this table of values that we now have and actually make a list plot of those tables values. And what this will do is actually, instead of just forming the table, we'll form the table and then plot them. And if we go underneath here and we just look at the command for list plot, this is one of our simplest situations for plotting, right? We are actually using this list plot here. We know what the output for that table is going to be. It's going to be this set of two valued sets, right? Sets of two variables, right? The x and the f of x value. And it's going to plot out this set of sets for coordinates, right, in the xy coordinate system. If I hit enter there, you can see now it gives me the list plot of those values. If I shrink this out, we get kind of a better view there, right? We have plotted those points from 0 to 10, and we can see how they plot along this vertical scale here, right? That is the list plot command, folks. And not only could I do it from 0 to 10, I could do it from 0 to 100, right? We can get all the plots from 0 to 100 if we wanted, right? We can make this list plot for really any particular size, right? I will tell you that the larger that upper bound, you will put a little more strain on Mathematica, right? And you may actually time out within the system, right? That is some of the limitations you run into the basic programming here, or being on the basic plan. But in most cases, it will run for you if you don't put too much strain on the system. Now, you can make three-dimensional coordinates. Let's see here. Let me hold off on doing that. Let me stay in the 2 dimensions for just the moment here before we go 3 dimensionals. There's a few things I want to show you in 2 dimensions, and this video is starting to run rather long, so maybe I'll come back and do another quick video with you over graphing in 3 dimensions. Right? But this was making that plot of values, right? If we go run this just again, right? There's our plot from 0 to 10 for values of x. If I wanted to actually graph f of x, in 2 dimensions, f can be graphed by using the plot command. And I can come back here and plot f of x. Right? Now if I go over here and do a little search on how to use the plot option, right? The plot operator, right? This is the most fundamental way I can plot. All right? I can plot function f. We see that started here, where I do have to follow this with this little bit extra bit of information. What I'm going to need to tell Mathematica is what variable I want to plot with respect to x, in this case, starting at what value of x and continuing up through what value of x. Over what domain values do I want to form that plot? And this does have to follow in a set of three values, following a comma after our function here. And you can actually see down here in the plot window, Mathematica is waiting and saying, hey, I need something else here if you're going to use the plot command. So if I go in there and I put down the comma now, and then I lay out my brackets to make my statement here about x, you will see that right arrow goes away, and I'm going to plot x, let's say, from 0 up to that value of 10. All right, to go right along here with my table. Now when I hit Shift Enter, right, hold on, I didn't run for, it's too quick there. Hit Shift Enter, I do get the list plot that I was performing before, followed down here with the actual plot of this function, right? The continuous plotting of this function. All right. You will notice that the scaling is a little off here, right? My x-axis is certainly not in scale with my y-axis, right? One of the ways you can get a little bit more accurate in your scale is you can change the aspect ratio of the graph, and these are all given underneath. If we were to do looking at the plot option here, right? We were to go under details and options, we would see all these different options we could attempt applying. And here, aspect ratio. The aspect ratio is a way that I can make the graph have a certain ratio with the coordinate axes, right? And the way we use some of these plot commands is following the inputted values that are needed in the plot command. I can make this, I can draw up these other option commands within that operator for plot here. And you can see following that set of x that were needed, I typed out aspect ratio, right? Again, that's a reserved term here, or a reserved operator, a reserved function in Mathematica, where this is a what we call a plot option, right? And the way we're going to assign this plot option a value or a way to behave is, you did see I followed that with a right arrow. Now, there's no way I can show you how to make this right arrow without pointing the camera to my keyboard, and I don't have that option available. But where I get that right arrow from is it is a minus sign followed by a greater than symbol. Right? If you take a minus sign and follow it by a greater than symbol, but you don't put the space, it points or becomes a right arrow. All right? Where in this aspect ratio, I am going to want a 1-to-1 ratio between the x and y axes. Right? And if I scroll down, I should now see a bit of a 1-to-1 ratio between those axes. I'm going to zoom out a little bit. Right? But that gives me more of a 1-to-1 ratio. And hold on there. It's not quite 1-to-1. Oh, I know what the problem is. What is the default is 1-to-1. What we need to do is consider how maybe the x and the y relate to each other. Maybe we want a 1-to-10? No, We want to go the other way. Not a 1 to 10. We want to make a 10 to 1 ratio. Right? And that should put it a little bit more into proper scaling. Right? If we were to make a 10 to 1 ratio, now it's in proper scaling. You can see if this is 10 units in length, that's in scale to the y-axis here. Right? In that 10 to 1 ratio. Now you can see why this is not always right? Might not always be what you desire, right? To have a graph that looks like this. So leaving it in an aspect ratio of 1 to 1 is not a bad option, not a bad default option, right? The other thing you might notice here, the range of the plot was kind of default in its settings. The graph did start at 0 and continue up through 100, all because those were the output values that we see occur from 0 to 10. But if I wanted to change up the y-axis in its behavior, I could use a plot option given by plot range, and I could consider plotting across a range from -10 up to just the value of 10. Right? And there you can see I get something a little bit more in scale, but not quite still the same. But it assumes now a range of values from -10 up to the value of 10 along my y-axis. All right. In addition to that, you may also want to make your graph a little nicer in terms of labeling those axes. We really didn't put any labels on these axes. So maybe we come back and we label this axis label, right? And what we might want to label, right? Again, this is going to be treated a little like a set. We're going to want to label the x-axis, right? And maybe we want to label the y-axis. Now you can see as I label these axes, right, I do use some parentheses, and that is a way of telling Mathematica that what is going into as an input here is a bit of text, T-E-X-T there. We're putting in some text in as these labels, right? If you were to use variables there, if those variables were defined above, it would actually assign the value of those variables to those labelings, right? Here we want to put in these values as texts, and this is the nicest way to do it. And actually, let's turn off this list plot for now. And you can see there we get our plot where we now have these labels on our x and y axes. All right. If I actually wanted to call out this as function f, that can be done with a command here. I can come over here to f of x and actually call out this value of f of x. And maybe we call it out as function f of x, right? Maybe this is y equals f of x. And you can see there it does call that out. Now, it does it in a very arbitrary manner. I could start to do things like set its points, right? Maybe I want to put the call out at the location 4, 5, right? And now it calls out f of x that way, right? Again, maybe I don't want it to point right here. Maybe I want to point it at the position given at, let's go with 3, f at 3, right? Now where it's going to point at in the graph would be where we would be at 3, f at 3, or maybe we ought to do 2, f at 2 and actually show that bit more dramatic change in that location. All right? Now it's pointing right to there. Because I got it at 3, sorry. 2, f at 2. Right there. All right. Right? So again, that's just playing around with what we call the call-out operator. Right? I applied that to function f inside my plot, and you can see there's all sorts of options that I was playing around within that operator there. All right? Perhaps I want to give this graph a color, right? Or I want to make it a certain thickness, or maybe I want to make it dashed or dotted versus solid, right? All that can be done with a plot style command, right? I can make a plot style that is maybe red. All right? That does give me a red graph. Or maybe I want to make a plot style that is thin in its graph. Oh, hold on here. Oh, okay. I was hoping I could show you this. Separated first. I don't think I can. Let's go with thick. No. How I combine, I thought plot styles could be played out individually. Actually, to combine them, you have to use what we call the directive operator. So if I want to make this red and thin, right, I would have to use the directive operator there. And you can see it did get quite thinner. I could use the command thick, right, and it's going to become much thicker, right? Or I could even come back and talk about, oh, what is that called? Plot? Thickness? No. Is it just thickness? And set it to be a particular value. Yep, I could do that too, right? I can make it as thick as, what, 2? Is that working right? I don't think that's working right. Yeah, that's, oh, I know what the problem is it's going awful thick. Now what's going on? Number like 0.1. There we go, right? I definitely need to scale down that value, all right, to quite a small number to have a defined thickness level, right? So I could put those commands in there. I could also come back and say, let's make this dashed versus dotted, or versus solid. Or maybe I use the command dotted, right? And it will produce a dotted line, right? What else could I do here? Well, again, we can see all those given if we search the command plot style. Right? Plot style is an option that's applied to plots, right? These are all the different directives we can have: dashing, edge form, face form, right? Point size, thickness, right? I called those all out, as well as individual colors, right? And these were being applied to a plot in general, right? Or if we go just under plot in general and we scroll down, you can see some of the things I was able to do here. I was able to, I used the call out command on function F. I used the label command in there, as well as the plot style command. Where's that at? Oh, these are all the call outs. Plot styles were, I believe, down here somewhere. I'm not mistaken. Oh, plot style command, right? I applied that similarly. And there are all these other commands. I used the plot range command in there. I used the axis label command. I believe that's up here. Aspect ratio we did. I think axis label is up further up here. Right. Well, nonetheless, we saw its operation in here, right? And this is all happening within this one plot, right, that we've been working with, right? Go ahead and run that again. The last thing I might show you is here how to combine plots, right? Before we come, I probably should start drawing this quick little demo to a close. But if I wanted to combine plots, I might say this is plot P1. You can declare plots, right, as we declared functions. I might call this plot P2. And you'll notice now when I input this, I don't get anything back because I've set declared all those. We're to actually come along and combine the plots into one, right? I can use the show command, right? With the plots called out as P1 and P2 within that command. Now you will notice here, this is what I have drawn, right? It did combine this list plot with this list plot, or with this plot, right? where you'll note, again, the list plot goes from 0 to 10 for x, but we've done a lot of limitations on what P2 would look like, right? It only has a range from 0 up to 10 in value, right? Or actually from negative 10 to 10 in value. And you'll notice it didn't plot the negative 10 aspect, all right? What is happening here is in your show command, first of all, any plot options that are available will always default to the very first plot in that command. If I was to change the order of these plots in the show command, it's going to now default to all the options we've set up in plot 2, right, and apply plot 1 in that picture. So you can see here now it's changed rather dramatically to look a lot like plot 2 with plot 1 overlaid into that picture. All right. Again, that is, just taking note of how these plot options or the order of the plots go into a show command. And you can actually put plot options into the show command. Not all plot options can be put into the show command, but you can put several in here. For instance, if I wanted to change the size of this image, right, I could do that with a plot option given by image size. And maybe I want to make this plot large in size, right? And I could produce this as a plotting that is large in size. Or maybe I want to have it fit on my document nicer, so I'll make it small in size, right? I could apply these plot options here. And not every plot option works here, folks. There are certain ones that are combinable overall into the show command, and you can search the show command to list those out. And then there are some that are very specific here in your list, right? And then I was thinking the one, this is, again, I'll go back to really some of the fundamentals of working with Mathematica, right? Maybe I'll make this my fundamentals video, to kind of a starter video, where I'll come back and show you here, because we are getting a little long at an hour in length here. Let me come back and show you how to do a bit more advanced graphing in two-dimensional space, right? And maybe head down some of those Calc 3 roads that I know you folks are all waiting for. All right, but I will come back to that video shortly. All right, see y'all then, folks.